good afternoon. Thanks for coming. I know it's kind of late in the day, almost on the end of the event. Everybody must be tired, start falling asleep in the sessions, usual deal. So I appreciate everybody being here. This talk is about offline-enabled data services. And I'm sure you heard the word services a number of times during this PDC. And there are certain scenarios where you have a system that naturally lends to being always connected, always rely on having line of sight with that service that your system relies on in order to operate. However, you have to wonder what happens on those cases where the very nature of the application makes it that either you cannot rely on being connected to the service, or you know that in certain cases you won't be connected at all, or perhaps you're connected, but the bandwidth cost or the ability to gain more bandwidth is just not practical or not appropriate for the nature of the operations you're going to perform on your data. So in this talk, what I want to do is I want to discuss the early stages of a technology we've been working on that effectively allows service authors, people creating services, and service consumers, people consuming services, to sync-enable services and then take the data that is behind those services offline for offline operation. So my name is Pablo Castro, and I'm an architect on the data programmability team at Microsoft, part of SQL Server, part of the building that cares about data in many aspects and sort of covers a lot of the ground that all of the groups that are involved in creating these solutions. So the way I wanted to approach this is I wanted to spend a little bit of time talking about what we think is the problem space. Since it is very early, this is the phase where we ask the questions about what problems do we think we need to solve. So validation of the problem is very interesting. And after the talk and during this couple of days, and later on through the web, I'd be curious to hear if you think this is the right spot and how we should tweak it. And then I'll spend some time, probably most of the talk, in Visual Studio, showing what we think is the right experience from the developer's perspective to create and consume services in an offline manner or using synchronization. Then I'll spend some time looking into the details of how things happen under the covers. And then finally, I'll do the standard roadmap drill. This being an early thing, you'll probably have a number of questions about when do I get it, do I get it, what does it look like, and so on. So let's drill right in. Let me first spend some time on the motivation. There are two key words that come from the title of this talk that I want to highlight. One is why offline, and then why services. So offline, as I said before, maybe offline is too much in this case, but it's in general, when is it that you have an application that depends on a service, but for certain tasks of that application, you don't want to rely on being able to access that service, either because of lack of availability of connectivity or because bandwidth is not appropriate or whatever. And why data services? Well, we do have already a number of technologies that allows you to do synchronization. At the database level, SQL Server itself comes with things like merge replication, transactional replication, and other options. On the Visual Studio side of things, we have things like the OCS, the Occasionally Connected Systems infrastructure, that allows you to point at database and create like a direct sort of line of sight to the database synchronization based application. However, all of those things assume that you can go look at the database and that the data is stored in a traditional database. It turns out that right now, more and more data is actually sitting behind a service boundary. And the service boundary may be layered on top of a traditional relational database system, or maybe it's layered on top of a system that you don't even know how data is stored. So there is an opportunity here where for a certain class of services that are data-centric and that we can, which services we can augment with a particular interface, we can layer synchronization support on top of the interfaces of this service and allow these scenarios where constant connectivity with the service is not an option. So what are application scenarios that we have in mind? There is a ton, and I wanted to mention a couple of examples. First is the occasionally connected deal, or offline capable. And I'm sure there is a fancy way of saying this, but at least the way it works for me the most is anybody that used Outlook, that's what we mean. And I'm sure everybody has something to complain about Outlook. Any program you pick up that you didn't write, of course, you always find something that you don't like. But the higher order bit is Outlook really nailed the offline operation mode. I mean, it wasn't cheap. There's a bunch of people working on this system. But if you look at Outlook, it effectively is a one-tier application. There is a local store that Outlook uses to manage the messages. And the interaction model is between the user interface, and the local store. And then there is an independent interaction path that goes from the local store, the replication system, and the backend service. In this case, typically your mail server, maybe Exchange or something else. So very nice model, very clean to create these applications. We want to enable that as one example of something that needs to be very easy to do using this infrastructure. Another kind of problems that you may encounter is when it's not so much that you cannot connect, it's that what you're trying to do doesn't fit well into the bandwidth that you have available to you, either because bandwidth is not high enough or maybe it's just too expensive. So imagine things where in an application you do what-if analysis on top of a very large amount of data that changes very slowly. If you are going to scan this data constantly on the client, you may as well just bring the data locally and do all of your number churning locally on the client. And if there are updates going on the server, just bring them incrementally. And in fact, if you're making changes in the client incrementally, push them down to the server as they happen, but in a background synchronization task, while in the front end, you're continuing to manipulate the data locally at local speeds. Another dimension that is somewhat orthogonal to the kinds of applications has to do with the closed system assumption. Sometimes you'll build an application and you own both parts. You create a service, and maybe the service is in the end backed by a database or something, and then you build a client. And maybe this is even a single Visual Studio solution, and your team is working on it. The other case is when the service that you're consuming in your application is actually a third-party service. You may not even know the dude that created the service. All you know is there is an endpoint on the web, you have some deal where you can use this service, and that service, you need it for your application. So in that case, you cannot assume same Visual Studio solution. Clearly, that's not going to fly. So you need means to connect to services that you control and means to connect to services that you don't have any control other than the knowledge of the endpoint somewhere on the web. So based on that problem statement, what are we building? We're building this thing that allows you to take services offline, just to use a word. We are in the middle of the project. It's early enough that we don't have fancy names or anything. Since the Astoria team, the team that created ADO.NET Data Services, is heavily involved along with other teams, we call this thing Astoria Offline. And the goal of Astoria Offline is to provide an end-to-end solution that fully addresses the challenge of building this class of applications. We want an integrated experience inside Visual Studio, so you don't have to leave your sort of comfort zone to build these systems. We also want to fully address the synchronization challenge. Like part of the probably biggest chunk of the challenge of building offline or occasionally connected systems has to do with the synchronization stuff. So we have a technology called the Sync Framework, the Microsoft Sync Framework, that enables a lot of this. But they are libraries. They are very general purpose. We want to take it to the next step and provide all of the APIs, the algorithms, the formats, the protocols, every element of sync that you need in order to create a concrete application. Also, we want to do this in terms that make sense for your application. Instead of syncing low-level elements like rows, we want to sync whole entities, things your application can talk about. So for example, when you're talking about a conflict between two versions of a given item, you talk about a conflict in an entity that your application can make sense of, not a low-level record. And finally, environment setup is very important. In my experience, whenever you try to do something like synchronization, it's not just the libraries, it's the stuff you have to do around. Things like you have to go mess with your database schema to track synchronization information. Or you have to go change your mapping or models in order to give us synchronization hints. And all of those things that you have to do that are very tricky and put a sort of a high barrier of entry in creating these applications. We want to make sure that, at least in the initial path, all of these aspects are addressed for you right there in Visual Studio as you go. And of course, later on, as you understand the problem better and the technology better, you can take over and remove our default choices for this and put your own stuff. Finally, sort of consistent with the Astoria history of having open interfaces, we want to do this in a very open way. We try not to invent too much. We are reusing technologies as much as we can, and we have an open interface, simple HTTP-based interaction model to actually synchronize nodes. You know, if you use our tools are built on top of this model and provide a very nice end-to-end. But if in one of the nodes you don't want to use them or you can't use them and you want to roll your own, you're welcome to, and you will find all of the elements to do that. So, you know, this is kind of a rough technology, so I thought I would go with rough diagrams instead of all of these fancy things. Thank you. So this is an example of an application model that you can be building. This is the Outlook-ish example, where what you have is a service on one side and the offline application on the other side. So the service, yeah, I had to get fancy at some point. The service is a data service. And when I say data service, I mean an AD.NET data service. Do people know AD.NET data services or Astoria? A few. Actually, oh, people kept going. So an AD.NET data service is a simple web-oriented service that exposes data from an underlying data source using a RESTful interface. So very web-friendly, very simple interface designed to expose data to other systems. So in this service, you have your business logic. You have the data access layer that accesses whatever is your data store. The system is very flexible, although in practice, most of the time when you're building these things, you have a relational database underneath. And also, we have the sync magic there, and I'll drill into that later on. These services exist in the online on-only manner, and we already shipped this technology. So the online part, it's already there. It's in the .NET Framework 3.5 SP1. The new thing here is you can now go in and sync-enable a service. Once you have a sync-enabled service, what you do on the client is write a vanilla one-tier application. You have your own local store, and the local store has a schema that reflects the service schema. Again, service. Like, never assume that what's back in the service is a database. It's whatever the service interface, the contract on the service exposes. So the idea here is that data coming from the service fits into the local database schema, and the data or changes you make in the local database schema fit back into the service. And then in the background, you have synchronization going over HTTP. Of course, I'm picking very specific things here. You can use the building blocks and generalize, but what we want to do is, instead of being always saying, yeah, it's general, and then it's always a lot of work to build something, we want to build something and then give you the building blocks as well. The other thing I want to highlight is that even though this service is sync-enabled, it is still a data service. Excuse me. That means that I can simultaneously have online clients and synchronization clients against the same service. And you can imagine scenarios where I have maybe an Ajax application or a Silverlight application that is running, fronting my service online. And then I also have a rich client experience, maybe a WPF app, that takes this application, the data in this application offline for offline use. So these hybrids just work out of the box. So with these elements in mind, let's switch to Visual Studio and build this Outlook-ish application. So what I have here is Visual Studio 2008 SP1 plus the sync stuff that sort of is the output of this project. There is enough stuff there to pretty much guarantee at least 1 or 2 crashes. So, you know, bear with me as I deal with it. And I want to start by building the service side of this thing. So the service side is a data service. I'm not going to build the UI. I'll focus on the service for now. And this service is a web service, so I need to host it somewhere. I'll host it in a website. So let's go ahead and create a new website. So I'll go here, say web application. We want a regular web application. Web app 45 is just fine. And in this application, you know, I'm not going to deal with UI too much, so let me close the default form, if I can. There. What I do want to do is connect to a data source. So as I mentioned before, we have a lot of building blocks you can build together. What I'm going to do now is what I call the piece of cake scenario. Piece of cake scenario means we will do everything for you. The goal here is to get you up and running with a sync-enabled system very, very quickly. Once you understand how all of the building blocks work, then you can go customize things. But we want to get out of your way. So what I'll do first is I'll connect to a database. The piece of cake scenario works under the assumptions that you're using a relational database system and you're using the entity framework to access that database system. Because when you do that, we can introspect the database and introspect the model in the entity framework and automate a lot of things. Of course, there are cases where you don't have a database or you don't have the entity framework or you don't want them. And in that case, you can implement a bunch of stuff manually and still get the same results. So that was a long way of saying I'm going to add an entity framework thingy. So let's go here, entity framework. And I was trying to come up with what lame example I was going to use for this thing. And the one thing that everybody, or at least most of the folks here, is going to do is a bunch of expense reporting this week, right? So let's build a small offline capable expense report. So you can do it, use it here, in the hotel, in the plane. There's always the plane scenario, which people don't fly that much, but it works well for offline cases. So let's do expenses. So the EDM wizard runs, and I'm saying I have a database already. So I'll say, give me a model from the database. And I'm going to choose the expenses database in my local SQL Express. This is arguably your server, right? And the default name here is good. Click Next. So now the wizard goes to the database and looks at the schema, and it offers me the objects that I want to pull into my conceptual model, my EDM model, and takes all day to do that. There. So simple schema. I don't want to get too fancy because I want to show you the changes we're going to make to the database. So I wanted to keep it as small as possible. So we have the expense report, the heading of the expense, if you will, and then the line items. I mean, of course, you got to trust me. This works on bigger databases and all that stuff. So click Finish. When I click Finish, the EDM wizard goes, looks at the database for the details of the schema, and produces an EDM model that is one-to-one to the database. I can take it from there and actually modify the mappings so that my model is not really my database, it's whatever is appropriate for the HTTP interface, for the data service interface. In this case, I'm going to be cheap because that's not the focus of the talk, and I'll just take the defaults. And sorry, let me open that again. I kind of closed it too fast. So this is the model. Model, again, has expense and expense items, and there is a one-to-many relationship going there. So now that I have a model, next thing I need to do is create a service. So we're going to create a new data service. Again, add new item, and I'll choose ADO.NET data service here. And this is going to be called expenses as well. And when I click Go, a new ADO.NET data services wizard comes up that lets me do a couple of things. If I say other, you get the V1 behavior, the one we're shipping, where you get a template and you get an online service. I can also create a service and at the same time bind it to an existing model. So I'm going to do that one. And the model I have is the one I just created, expenses entities. And isn't it great that we figured a way of having a single button that says sync it? So what the deal here is, if you say finish without clicking it, we will create a service that looks like a regular online service. Now, if I do click that guy, I'm going to click it so it goes. I get a bunch of flickering, and I'm hoping this is going to get better later. And the output is a service rather, that is a regular service, but it's also sync enabled. So let's define sync enabled by observing what this guy just did. 3 things happened. First thing is I got a service. The service is your vanilla service. So this is a data service object called expenses, and it's a data service over the entity framework model called expenses entities. Second thing we did is you gave us an input model. So we went, looked at that model, and augmented the model with the elements we need in order to synchronize data to and from that model. And I'll drill into the details later, but for now I'll just show you there is a bunch of stuff there that starts with sync. And we'll have a discussion of what it means later on. But this is things that by looking at the model, we augmented the model with that information. So then the rest of the system can operate. The third thing we did is we generated a bunch of scripts, actually 2, a creation and an undo script that will take my input database and it will transform it such that you can actually sync against that database. Usually, when you do synchronization, you need to track additional information at the database level in order to be able to do that synchronization work. depending on your topology and the synchronization scheme you're following, this may be of different kinds and different levels of support. For now, we have a approach, and I'll discuss the details a little bit later. For now, enough to know that there is a create script that does a bunch of stuff to my database, and then there is a drop script, because, I don't know about you, but I have this uneasy feeling when somebody comes parties on my schema. So what we want to do is to allow you to go try it, and if you don't like it, you run the other one and you drop all of the changes we just made. So let me select this, and actually I'll run it against my database, so the database becomes sync enabled. So I'll paste this here. This is SQL Server Management Studio already connected to my expenses database, and I'll hit go. And this will churn for a second, and should be done. There you go. So now my database is sync enabled. So last step. So now I have a database that is sync enabled and a model that is sync enabled. Last thing I need to do is I need to set up the service so it actually works. First, for those of you that are familiar with Astoria data services, know that by default, the system is closed down. We don't want to make it too easy to open an interface to the web where people can go do whatever with your data. So you need to enter the access rights for each one of the entity sets. We have this fancy demoware feature that says star. I don't want to think about this now. And I'm going to say all. So I'm allowing all access. Just don't do this in your apps. So this allows online access, but still does not allow synchronization. So I need to enable synchronization as well. We don't want to enable too many things just magically. We want you to opt in explicitly into this. So through the magic of versioning, I have to do this cast, because this is the version 2 of the interface. And I need to say allow synchronization equals true. So when you say that, we will open up the synchronization interfaces in addition to the regular online interfaces. So before I go further, let me actually run this service in the browser. It's not going to be that interesting, but I wanted to highlight the fact that even though I did all of this sync stuff on top of the service, this service is still a regular AD.NET Data Services service. So if I hit the root of the service, of course, your applications are not going to do this with the browser, but I'm going to do it just to illustrate the point. You get the service document that contains all of the URLs to the various sets. In this case, I have 2 sets, the expense set and the expense item set. And I can drill down. I can, for example, say expense here. And this will go to the database and retrieve all of the expense report objects, just the headings, and list them on as an atom feed, actually. And this bunch of XML is an atom feed. Let me collapse them and show you one. And you can see here that there is links to the relationships, and then there is things like the employee name, the creation date, and the description of the expense report. So online applications can continue to use the URL scheme and the standard way of interacting with the service to get information and, of course, update information, provided that the right authentication and authorization is set up. So at this point, we have a ready-to-go sync-enabled server. Let's do some philosophy, and then we'll talk about the client. So I want to highlight the fact that there's not a single way of using the system. What we want to do is we want to make it straightforward to go quickly, and then give you the options of using the building blocks in ways that fit your needs. So in the piece of cake scenario, if you have a relational database and you use the async framework, then and the entity framework, then what we will automatically augment the database for you with sync information, or rather give you a script so you can do it in your development environment and then give it to your DBA for the runtime. Second, we'll look at your model, your entity framework metadata files, and augment those with sync information. And third, you need to go enable the synchronization support in the server. And of course, every one of these steps, you can skip what we did and do your own thing. So as you get more familiar with this, you can customize stuff. So great, we have a sync-enabled server. Let's now build a client that's not going to look like Outlook, but in principle, it's going to behave the same way. So let me come here and add a client. As a client, I can use a number of things. A client may be another web server. Maybe this is a server that caches data or something. Or it could be a console app, or whatever. In this case, the client I'm going to create is a rich client, so I'm going to use WPF. And again, we'll continue with the naming pattern of WPF app 1, just fine. So we'll worry about the actual application and UI in a second. First, let's worry about the data. So if I was building this application against an online service, and this was an online application against this data service, what I would do is I would go to the add service reference option, add a reference to that data service, and then I will get a bunch of code, like classes for each one of my entities, and maybe an entry point, and then I will have online interaction with the data service. We wanted to sort of extend that gesture, that metaphor, such that if the service happens to be offline enabled, then we can also give you the option of creating an offline client in addition to the regular online client path. So let me actually go ahead and do that. So we should have, did I close it? Yeah, so let's open the service so you can take a look, and I also need to pick on the URL. Hello, there. So that's my service. And on the client side, what I want to do, what I want to do is add a service reference. This already exists, and what it does is creates a reference to my data service. The difference is this time this service is sync enabled. So let me put a small aside here. At the beginning of the talk, I mentioned the fact that sometimes you can make a closed system assumption where everything is contained within your solution, and then you can do things like discover, and we find the service, and it's all easy. But sometimes the service is just some service out there, and all you know is maybe the URL to the endpoint and your credentials. So in that case, you can actually put the URL here without clicking discover, and we will do the same metadata exchange with that service. So let me click OK here. So this does, first, it will create the sort of the online reference and put it as a service reference there. And this is a long story, so I'll just not explain it. I'll just do it again. Bear with me for a second. You'll see that this time there is a question there. So let me zoom into this thing. So what happens here is the service checks, or actually the add service reference dialog checks to see whether the service supports synchronization. And if it does, it asks me whether or not I want to use synchronization in this service to take this data offline. So I'm going to say, yes, please do. And this is one of the cool parts, so you got to watch it. So, OK, I can't move it, but so there's a couple of steps we're doing here. We pulled from the service description, the metadata that says what the data in that service looks like. Based on that metadata, we come locally and create a local database with the right schema to hold that data. Third, we go create an entity framework model so that you have an instant data access API on top of the database we just created. And the cool part is that data access API uses the same model as the service. So the online path and the offline path use the same entities, same relationships, the exact same model. And then finally, thank you. Thanks. Finally, we sync enable the whole thing, of course. Otherwise, it wouldn't be that impressive, wouldn't it? So now I have my service reference, and I have a model and a database. Before I forget, let me switch something here. Again, long story, all that. And let me open this thing. So I have a local database. In this case, I have a SQL Server Express database. I could also have a SQL Compact database, which is nice because it's like in process and all that. Let me double-click on it and open it. And if I inspect the database, I'll drop down the tables and zoom in here so you can see. So you can see that I have the expense and expense item tables, and also a bunch of metadata goo that I'm going to discuss later. So this schema is the client schema. It was derived from the server. I want to highlight again, this is derived from the model. The fact that it matches the database is because I'm too lazy on the server and I didn't change the model. So second thing we created here is we created an EDM model. Again, the model looks just like the server model. And you don't even know how this model was produced in the server. The important thing is that you want to match the local model and the service model. So at this point, we're ready to build a quick one-tier application on the client. And I want to highlight the fact that the interaction model, for these things to work well, if you're going to build an application that may not be connected, then the most common user to UI to local store interaction path should not actually rely on having a connection. So we're going to build something that is local all the time, and then having a sync path on the side. So for that, I'm going to use the WPF guys just shipped a very nice grid control. So I'm going to add a reference to that, so we can use it in my application. Let me hit browse here and add these two guys. There. So here's what we want to have for a UI. First, on the top of the window, what I want is a couple of buttons. I want a save local button that if I'm making changes, it pushes them to a local store. And then I want a sync button. This you may do on the background. But for the example, I want a button that we can click to force synchronization. So let me copy-paste SAML to do that. It's a bunch of SAML, so I'm not going to type it on stage. Let me take this here and do this. So at this point, we have the header, 2 buttons there. So now on the left panel right here, what I want is the list of all of the expense reports that I have so I can choose each one of them. So this is the second part of the SAML. And there is a list box here. The rest is just formatting GUI. There is a list box here called reports that contains the list of reports. And here is my control here. Lastly, I need the centerpiece, which has the header of the report and all of the line items for that particular expense report. And this is the SAML I have here. And this is the last piece of SAML I want to copy-paste. So that should show up there. So let me save this. So here's our user interface. So the one thing I was thinking is, the technology is rough, the drawings are rough, and we have this really cool user interface designer in developer division, and she built something really cool, so I couldn't resist using it here. Check this out. So I'm going to drop in a bunch of resources, override my resources file, and now my UI is rough as well. It's pretty cool, isn't it? Then you wonder why we don't have time for anything. So let's actually build an application now. So there are 3 primary paths for data interaction here. One is when the application starts, I want to load all of the reports and put them here. Then when you click on a report here, I want to load the details of that report and put them in the main part of the window. And finally, if I change data and hit the save button, I want to save the data locally. And since we already set up an entity framework data access layer for you, I want to use the entity framework for doing all this. So let's start by loading the data when the application loads. So for that, the entity framework already generated an expenses entities, which is the class that represents the entry point to the database as a whole. This is the context class for those of you familiar with the entity framework. So what do we need to do here? We need to basically write a query that loads the report list from the database. So I'll create a method for this because we'll use it from a couple of places. Oops. There. So first, I'll initialize this. Since we're loading all of the data, I'm going to create a new one of these guys. And now I want to write a query and data bind the results to this reports object. So I'm going to go reports.ism source equals, and I'll write a link query, say from ex in db.expenses, maybe order by ex.creation date descending, select, and what I want here, I want the ID of the report, the description, and the creation date. And then finally here, we want to call load data. And this one is going to initialize the thing. Since I just created my application, the database is empty. So I'm not going to run this guy. It's not going to be very interesting right now. So let's keep going. Second step here is when you click on a particular expense here, I want to see the full expense report. So we have to go query for the complete header and also for the detail lines. So let's go do that. I'm going to click here, go to the event. I think it's selection changed here. And we want to write some code here. So first thing we need to do is make sure that something was actually selected. So we'll go reports.selected value. Selected value is not null. So if it is not null, we have something. Let's grab the ID. Int ID equals, cast to int reports.selected value. And now we want to write a query that retrieves this one report. So I'll go query equals from ex in db.expense reports. And I want to retrieve the expense report and all of the line items in a single go. So I'll use the include feature. So I'll say include expense item, which is the relationship between the expense and the expense items. So this will bring for each object the header and the details in a single go. Very nice. I have one of them that I want, is the one that has ID equals the ID I got from the list box, and just select EX. So now I either have 1 or I have 0 because the thing was deleted or something while I was doing this query. So I already set up in the XAML file, I already set up data binding so that everything is wired up. So the only thing I need to do here is say root.dataContext equals q.first_or_default. So great, now we are displaying the thing. Last data-related step is we said that if you mess with the form, when you click Save Local, we want to save it to the local database. So double-click here. So that means here I want to say db.savechanges. And that's it. You gotta love these ORM thingies. Like they do a bunch of work for you. So at this point, I have the entire path for local access. So now, in order to get data down in the first place and then exchange data up and down, we need to actually synchronize stuff. So this is the part where we actually build some synchronization code. In this case, I'll build the code against a button. You can imagine doing this in the background and in a number of places. So let's double-click here, and let's build synchronization support. I need to add 2 namespaces. One is the sync framework namespace, Microsoft.synchronization. The other one is the support for the entities for synchronization. This is in the data entities sync namespace. And so now here we can synchronize. Here's how synchronization works. We use the sync framework, and the sync framework has this concept of an orchestrator. What you do is you create an orchestrator, and then you create a sync provider for one end, a sync provider for the other end. You plug them in the orchestrator, and you say go. And the orchestrator orchestrates the synchronization dance between these two guys. And sync providers can be of different kinds. In the particular setup that we have here, one of the endpoints is the data service, so I'm going to use a data service sync provider. And the other endpoint is the entity framework, so I'm going to use the entity framework sync provider. So let's do all that. Data service provider is new data service sync provider. This guy takes a URL. These things take different input depending on the nature of their backends. So this one takes a URL, so I'm going to go to the browser, pick this up, and here say, whoops, new URI, paste this, and then completely arbitrarily, I'll say global here and talk about this later. So now I need the entity framework sync provider. Entity framework sync provider is called object context sync provider. This argument is much funkier, and you'll have to sort of bear with me. I'm sure we're going to have a simpler option in addition to this one. This one takes a function that produces new instances of the context class, the class we use to talk to the database. And if we use Lambda syntax for this, it looks like this. Expenses, entities. Of course, at this point, you may be wondering, well, you knew that, and you also knew the URL, and you know the number of names of those classes. Why don't you code gen this thing? And that's a very good question. This is the things that happen when you make random decisions on the spot. Sanjay was building this, and he's actually sitting down there, and he was like, hey, do we do this code gen thing for PDC? I was like, whatever. I'm not sure it's that interesting. And after building the demos, I'm realizing that this actually is not that nice without it. So we'll probably cook up something to do code gen for this part. For the time being, we have to deal with this. So last step here is I want to build an orchestrator. So sync orchestrator. And now I'm going to set the remote endpoint to the data service provider, the local endpoint to the entity framework provider, and finally, the sync direction, I can choose to do only upload, only download, or both ways. In this case, I'm going to upload and then download. Once I have everything set up, I call sync. And the magic happens, and we actually synchronize the stuff. So, of course, real world is not that nice. Sometimes synchronization doesn't go well. So let me put some very sophisticated error handling around this guy. If things go well, I'll go message box.show sync done. If things don't go well, there, message box.show this.ex.message. I'm sure you'll do nicer with your users. And finally, since I just synced, my data probably changed, so I'm going to call load data again, so I reload all of the data that's bound to my window, to my user interface. So at this point, we are done. These are all of the building blocks for the application. So let me save everything. And so the service is already running, so I only need to run the client. So let me change the startup project here. So we actually run the client. That should do it. And so I'm going to hit Control F5. Let's see if everything compiles first. Looks like it did. And now it should start. So I do have some data on the server already. And the first synchronization session, empty on the client, full on the server. So it's going to have to go bring all the information down, which is not what it's doing now. Who knows what it's doing now? There. So here's my user interface. Nothing interesting now because I have no data. So I'll hit sync and then wait. And we take a little bit of time. Data set is relatively small, so it actually should go pretty fast. So now I have to fill this with a bunch of comments until the thing actually comes back, because it does take a while right now. Of course, over time, we'll do better in this space. And you'll see incremental synchronization is pretty fast, too. OK, there. So now we're synchronized. So we have my expense reports. And as I move over the expense reports, I have my data here. And this application now is completely offline. This is just like Outlook, quote unquote, a small delta of functionality. So this guy is working against a local database, doesn't depend on any connections or anything, and it's fully read-write. So let's mess with this a little bit. Let me go to one of the tables on the server side, which is this guy. And let's open the expense table. Show table data. So this is the data that sits on the server database. And since we just synced, this matches exactly what I have here. So let's make, let's say, a couple of changes here. I'm going to say this is in LA. And maybe this guy here is in, I think it was in Orlando. And I'm going to hit Save Local. When I hit Save Local, these things are going to be saved on the client. And if I go here and refresh, nothing changed on the server, because I didn't do anything to the server. So now if I come here and click Sync, when I click Sync, the synchronization is going to go. And if I go to the server now and hit refresh, then the server is synchronized. Thanks. Of course, I'm not going to go into proving that every single aspect works, but you can add new things, remove things. And this is two-way. So if I remove, let me change this on the server. I'm going to do that. And then on the client side, let's take this guy here and say this is in Las Vegas. There. Save local. So I made a change on the client, a change on the server. Like, all of these combinations work. And you can add records, modify records, delete records. So now this one says Los Angeles, and this one here should say Las Vegas. So now a change from the server went to the client, now another from the client went to the server, and the whole thing. And if you add and remove things, we will add and remove things on the other side. So great, we have an Outlook application-ish, a little bit short of features. So what just happened? We created a sync-enabled client. And again, we follow the piece of cake flow, or the scenario. The piece of cake scenario on the client is you use add service reference. We detect that the service is offline, and we download the service metadata, create a local compact or express, in my example, database, set up the entity framework so you have a data access layer ready to use, and we add sync support both to the database schema and to the entity framework. Of course, by definition, whatever strategy we pick is going to work in some scenario, and it's not going to work in a number of other scenarios. So all of these are building blocks that Visual Studio is just using to orchestrate this scenario. You can also use the client-side building blocks. Here's a good example of it. One of the endpoints I used is the entity framework sync provider. And in the other end, I used the data services one, but there's nothing that prevents you from using an entity framework provider on both sides. And now you can do sync from entities to entities directly, assuming that you get line of sight of the database servers on each side. So there's a number of things you can do around this. In the example I just did, I used a number of technologies, and I wanted to highlight what are the building blocks that we're using and extending in order to support this. So we're continuing the RAF theme. And on the server side, we have RESTful data services to expose the data. And for that, we use the data services framework. In order for the server, in the piece of cake scenario, to discover the shape of the model and do data access, we use the entity framework. But of course, if you have some custom data source that doesn't look like a database, you can, even in the existing version of data services, you can override this with a custom data source. And when we did sync support for the entity framework path, we did it in a layered way so that if you have a custom data source and you want it sync enabled, you can implement the proper interfaces. Not exactly a piece of cake, but you can. And at that point, you get synchronization enabled for your data source as well. In the server, when you're using the entity framework, in principle, you can use any server that is properly supported with a provider. We have kind of an emotional attachment to SQL Server, so it's nicer if you do that, but there's no technical reason other than maybe faster or better or all of these things. Of course, when it's sync magic coming from somewhere, that somewhere is the sync framework. And a lot of the algorithms, the metadata management, and many other aspects of the sync-related activities happen based on the sync framework. On the client, I used any regular technology to build an application. I used WPF. I could have used a web application with ASP.NET, a console app, whatever is appropriate. And we used the entity framework for local access. And we set up everything you require for using the entity framework automatically. And as a store, you can use SQL Server Compact, or in the case of my example, I used SQL Server Express. And on the client side, we also use the sync framework, as you saw with the orchestrator and all that stuff. We use the sync framework for synchronizing things. So far, so good. In reality, there is a number of features or requirements that real applications that do synchronization need to deal with. So how do we address many of these common needs? Let me start with business logic. On the client side, business logic is relatively straightforward in the sense that you already probably have a path that goes from the UI layer into whatever business logic you can enforce or want to try to enforce on the client before you actually land on the server. You may want to, in addition to the regular path, some sync events. But in principle, you can do what you're doing today. The server, though, is trickier. Because what happens is now you have an online path, which is the path that clients of the data service use to talk to your data service in an online manner. And then you have the synchronization path, which is the path in which you will receive and send data when talking to synchronization-based clients. So what we did is we said, well, we have already metaphors to deal with how you intercept on the way out of the data and on the way in of the request from the clients. So we extended the concept of query interception and change interception that we already have for the online case so that they also work during synchronization. Query interception happens whenever we are querying for entities on the underlying store. And what we do is we allow you to give us custom filters that we compose with whatever queries you are building, so the output is the resulting subset. And this can be contextual. They can be based on the current authenticated user, or in the current role, or maybe joined with some access control table or things like that. Change interceptors are more procedural, less sort of the query composition based. And what change interceptors do is they get called during creation, update, or deletion of any entity in the system. So you get an opportunity to look at the entity, validate whatever you want to validate, kick off background processes. Maybe when you change certain property, you kick off a workflow or something. And finally, choose whether or not you want that particular operation to succeed or you want to fail it. So that was a bunch of stuff. So let me actually bring it down to a concrete example. So let me go to the server side for a second. And in the server side, I want to introduce a very simple rule. By the way, these services, in practice, services never look this clean, right? You have a bunch of rules for restricting who can see what data, who can change what data, and so on. I'm oversimplifying that a little bit. So let's put a rule here. This rule says, whenever you're creating or updating an expense report, it cannot be too far in the future because it's kind of weird. You're not supposed to know what you are going to expend too much out, right? Too far out. So let's put a change interceptor that enforces a rule of every activity on expenses need to be at most 30 days out and no more. Kind of lame, but it's the only thing I could come up with. So I'm going to say on change expense. And in change interceptors take the object they are intercepting, in this case expense E, and the operation, so update operations operation. I also need to tell the data service that this is a change interceptor using the change interceptor attribute, and I'll say I want to intercept the expenses entity set. What do we do here? We get called here if somebody is causing a side effect on a particular expense. I'll check to see if the side effect is a creation or a change. And if it is, I'm going to do the check on the expense itself. I'll say if expense.createdDate is greater than datetime.now.add days 30, so more than 30 days out, we'll throw an exception because this looks too weird. So I'm going to throw a data service exception that says, well, too weird. Again, you probably do better in your apps. So there you go. And the important thing is this thing runs no matter how you're affecting this entity. This could be the online data access. Maybe somebody did an HTTP put, or it could be the synchronization path. So let's try this out. I'm going to come here, and first I'll sync without changing anything. It's not going to be a lot of fun, but it should sync, and so it goes well. And now I'm going to say something like, I'm going to change this to 2009. That change didn't stick for some reason. There. Click save. So now it's 2009, and I click sync. When I click sync, nice. Did I save it? Oh, I didn't build the service. Man, thank you. Awesome. I don't know. Let's confirm that. Let's come here. 2009. So let's look at the service. There's something funky going on. Oh, man, you're already an expert on this thing. I totally missed that. Isn't it good to have a whole team here working on this? Okay, save local, sync. Man, you were right. There you go. So, too weird. You know, don't do that. Don't change something that is too far in the future. So, of course, I'll keep getting this message as long as there is a problem here. And so right now, this example is actually not quite good because I synced a single item, and that item caused an exception. But typically, you sync a bunch of changes in a single go. And the way we want to approach this, which doesn't quite work yet, is we want to be able to mark each item that you fail as an exception and then make progress with the rest of the graph. Sometimes when one item fails, a number of other dependent items will fail as well. But we want to, whenever it's possible, make partial progress as we get over the ones that don't fail. And eventually, you'll fix these things, and the synchronization converges again. Of course, like here, supposedly, if I go back to 08, that was weird. Oh, there. Well, I can't type anymore. Who knows why? I'll ignore it for now. So I'll get back to this in a second. But what I wanted to highlight here, let me just close and open this thing. So what I wanted to highlight is once I fix the problem, if I go back to 08, then that item syncs, and then the exception that we were tracking gets removed from the place where we track the exceptional cases. We'll wait this for loading and then try it again. So this was this guy, right? So I want to say 08, and maybe just 28 here, and that's all I meant when I was making the change. So I'll click Save Local. And eventually, when I click, whenever I synchronize, maybe in the background, maybe here, like I'll do the synchronization the first time, and this time this should go through. And if I come back here and refresh, this is back to the 29th, 08. So you get to handle the errors and stop the synchronization when it doesn't make sense. And then once you unblock that, the synchronization goes through again. So another aspect, conflict detection. Whenever you're synchronizing, conflicts are bound to happen. Conflicts happen when you have more like two nodes in your topology making a change at the same time, in the sense that we think to sync sessions to the same item. And so we will take care of conflict detection, and we'll do precise conflict detection. We'll avoid false conflicts. But what we do when we detect one is we call a handler, and you need to take it from there and provide a resolution policy. We have two spots where you can handle conflicts, on the server side and on the client side. The idea is sometimes the conflict, in order to resolve a conflict, you need user interaction. We need to prompt the user and say, hey, I have this conflict. Can you sort it out for me? When you do that, it is more appropriate to handle the conflict on the client. On the other hand, sometimes you have policies, things that are automated and they are strict and they always need to happen. And you don't even trust the clients to do it. So for those cases, you can also handle conflicts on the server. And if you handle them on the server, then well, there's nobody to answer any questions, but you can do it automatically if you have a criteria that can be executed without asking anybody. So let me show you a quick example of that. So I'll do server side. Client side is very similar. So on the server, on the client, we use the Sync Framework API for conflicts. On the server, since you're running inside the hosted environment of the data services framework, we have a virtual in the data services that you can use, you can override and get called there. So I'll override this function called resolve conflict. And let me shorten this crazy namespace here and re-resolve this. And so when you get called, what you get as a parameter is two of these sync record thingies. Sync records contain some information about the target and the actual object. Not the object instantiated, but the properties that make up the object. And you get the source change and you get the target change. So effectively, you're getting the change that the client made and the change that the server made, and you get to choose what to do with these guys. By default, we do nothing, meaning we simply mark this as an exception and don't synchronize them, so the conflict remains. And the nice thing about that is you can make progress everywhere else without sorting out a conflict, which sometimes is desirable. In this case, I'm going to create a very simple policy. What I want to say is, I know what the header of a expense report looks like. So my arbitrary rule is, whoever has the latest date in the created date field wins automatically, without asking anybody. I'm not sure this is a great idea, but works for the example. So since I may be called here for any of the entity sets that I can synchronize, I want to check and make sure this is the expenses entity set and not something else. If it is, then I need to extract the creation date from both sides. So I'll go bar source date is date time source change, and we have the properties collection which contain all of the properties, and from here what I want is the created date. And similarly, in the destination date, same thing, date time, this time is destination change dot properties, oops, created date. So now I'll make a check here. Actually, I can even say return. If the source date is greater than the destination date, then I'll return sync conflict, not that, sync conflict resolution action dot, and I can choose whether, when I return from here, I can choose whether I want one of the sides to win, whether I want to merge the records, or if I want to just keep the change and keep the conflict sort of standing until next time. In this case, I'll say if the source is greater, then the source wins. It helps a lot if I actually use right syntax. Otherwise, if the destination goes later, then the destination is going to win. So there we go. So now we have, there we go. There. You gotta love those squiggles. So now we have an automatic resolution policy for the particular case of expenses in this case. The items, for example, I didn't handle. So let's build this guy. That's fine. That means that it can't copy the client. And let's cause a conflict and see how it goes. So let's refresh this. So this is 1029.08, and here it should be 1029.08, the same thing. So here I'll move it to a 28. Let's make sure it sticks because it didn't last time. It did. Great. And then here I'll move it to the 27th. So by default, when you do something like this, what we do is we don't sync it because we don't know who, I mean, if we sync something like this, we would lose information. So in this case, what's going to happen is the handler gets called and we get to resolve which one wins. So if I call sync here, and a number of things go well, there. So this was 28, this was 27, and now this guy is 28. So we resolve the conflict automatically, in this case, on the server side. All right, so two more elements that are common requirements. One is you may have a lot of data and a lot of changes. And you cannot assume that a single sync session can sync the whole thing in a single go, because connections go down, so connections are unreliable, and more in general, it's just a fragile approach to this. So we are working on batching. so that we actually send the changes in batches to the server, and also in incremental progress and dependency management. What that means is sometimes you have, actually oftentimes, you have what effectively is a connected graph. You have a bunch of entities that depend on each other. So one of the things that most frameworks actually don't do, and we are going to fully automate, we have part of it already in place, is all of the dependency management aspect, where we're going to do batching, and each batch will actually contain proper dependencies in proper order. So we are not going to run into our own foreign key constraints, at least as long as we are told about the foreign key constraints in the model. This is a very tricky area. It's very difficult to sort this out on a particular like case-by-case basis. But it turns out that you can generalize it if you spend enough time doing it. And once you solve it once, it works for everybody. So we're going to do that as well. It's not perfect. There is a number of corner cases, like pathological cases, where the whole thing becomes a loop, and you cannot actually, you have to sync the whole thing. So there are some scenarios. But in general, we can facilitate this a lot. So finally, so far I've been syncing everything, which maybe some scenarios work like that. But very, very often, the data service contains more data than what you want to bring locally. So you want to be able to take a slice of data and bring it locally. This is what we call scopes. And at the very beginning, when I was typing code and put the word global in my request for the server, that's the global scope, because right now we didn't implement them yet. So we have a scope called global. But the idea is that you define scopes, and then what you sync is particular scopes. So last thing I wanted to touch on requirement is the security considerations. So if you look at the application, let me switch real quick here. The application we've been building so far is actually hosted in ASP.NET. And in fact, since I use the default, if I open web.config and you look at the connection, the authentication information here, this was actually running on Windows Auth. That means that if I don't have a credential to log into this box, you cannot access this service. So you can use the existing authentication schemes supporting ASP.NET, or even the custom ones based perhaps in HTTP modules and so on, to also secure the synchronization path in addition to the regular online path. Of course, like authorization only tells you who is the guy on the other end. Oftentimes, most of the sophistication related to security in an application comes from the authorization part. So the query and change interceptors have full context of where you're running. By the time we call them, we are already post-authentication and everything. What that means is, for example, you can have queries and change interceptors that check for the username or the role of the user or things like that, just like I check for the date in my small interceptor example, and either stop an action from doing it or tweaking the behavior based on your role, or sort of in general adjusting how the system behaves based on who you are. So I'll just spend a couple of minutes on the details before we wrap up the session. I just wanted to touch on a couple of key aspects that, on how the system is built that provide extensibility points for you to work in. I want to touch on the synchronization strategy, interaction model, and finally on the requirements for the data itself. From the synchronization strategy perspective, we use the sync framework, what means we inherit their multi-master replication scheme. That means that, in principle, we carry enough metadata, and the algorithms deal with scenarios that go to the point where every peer in a mesh can synchronize with any other peer, and not only convey information about itself, but information about other peers it knows